Picture this. It's raining. But it's not water falling from the sky, it's gasoline. Methane, to be exact. Lakes the size of the Great Lakes filled with liquid methane. Rivers flowing with hydrocarbons. And somewhere in this alien world, there might be life forms swimming in those toxic lakes. This isn't science fiction. This is Titan, Saturn's largest moon. And in 2034, NASA is sending a nuclear-powered drone to fly through its skies and search for alien life. Yeah, you heard that right, a drone. On another world, looking for aliens. And here's the wildest part. Titan might be the best place in the entire solar system to find life outside Earth. Not Mars, not Europa. Titan. This orange, hazy world a billion miles away could answer the biggest question humanity has ever asked. Like, are we alone? So let's talk about why NASA is betting $3.35 billion on a flying robot to explore Saturn's strangest moon. But real quick, if you're into missions like this and want to see more wild space exploration content, hit that subscribe button right now. We've got Europa, Mars missions, black holes, all the crazy stuff NASA and SpaceX are doing. You won't want to miss it. All right, let's get into it. Titan is bizarre. It's the only moon in our solar system with a thick atmosphere. In fact, its atmosphere is denser than Earth's. If you stood on Titan's surface, the air pressure would feel like being 15 feet underwater. But don't take off your helmet. That air is mostly nitrogen with methane clouds, not oxygen. The moon is massive too. It's bigger than the planet Mercury and about 50% larger than our own moon. But here's where it gets really weird. The surface temperature is minus 179 degrees Celsius. That's minus 290 Fahrenheit. At these temperatures, water ice is as hard as rock. And that's exactly what Titan's surface is made of, rock-hard water ice. But Titan has something no other moon has. Weather. Real weather. Methane evaporates from the surface, forms clouds in the atmosphere, and falls back down as rain. This methane rain carves rivers into the icy surface, flows downhill, and collects into lakes and seas. Cassini spacecraft observations revealed that some of these seas are hundreds of feet deep and larger than North America's Great Lakes. Imagine standing on Titan's surface. The sky above you would be a thick orange haze. The sun, over 1 billion kilometers away, would be just a dim glow through the smog. And if you looked around, you'd see dunes stretching to the horizon, mountains of water ice, and lakes filled with liquid natural gas. It's like Earth, but made of completely different stuff. And that's exactly why scientists are obsessed with it. When the European Space Agency's Huygens probe landed on Titan in 2005, the first and only landing in the outer solar system, it sent back images that looked eerily familiar. Rounded pebbles on the ground, a flat plain stretching into the distance, dark channels that looked like dried riverbeds. For a moment, it could have been Earth, except those pebbles were made of ice and those rivers once flowed with methane. But here's the million-dollar question. Could there be life on Titan? The answer is complicated. Life as we know it needs 3 things: liquid water, organic molecules, and energy. Titan has 2 out of 3 on its surface. There's no liquid water up top, but there are liquid hydrocarbons, and there are organic molecules everywhere. Complex carbon compounds raining from the sky like snow. When sunlight hits Titan's atmosphere, it breaks apart methane and nitrogen molecules. These fragments recombine into more complex organic compounds, things like ethane, propane, benzene, and even amino acids, the building blocks of proteins. Scientists call these compounds tholins, and they give Titan its distinctive orange color. These organic molecules accumulate on the surface over millions of years. Titan essentially has more liquid hydrocarbons than all the oil and natural gas reserves on Earth combined. And all of it is just sitting there, mixed with complex organic chemistry. Now here's where it gets really interesting. Beneath Titan's icy crust, there's likely a global ocean of liquid water mixed with ammonia. This subsurface ocean could be over 100 kilometers deep. So Titan has liquid methane on the surface and liquid water underground. 2 completely different potential habitats for life. On Earth, life exists in the most extreme places you can imagine. Microbes thrive in boiling hot springs, in acidic mine drainage, in Arctic ice, and in pitch-black deep ocean vents where no sunlight ever reaches. If life can adapt to all those environments on Earth, maybe it could adapt to methane lakes or ammonia water oceans on Titan. Scientists have even theorized what methane-based life might look like. Instead of breathing oxygen like we do, these organisms would breathe hydrogen. Instead of eating glucose, they'd metabolize acetylene, a hydrocarbon. And instead of exhaling carbon dioxide, they'd exhale methane. It would be life, but not as we know it. Life based on a completely different chemistry. But we won't know if any of this is real until we go there and look. And that's where Dragonfly comes in. Dragonfly isn't like any spacecraft we've ever built. It's not a rover like the ones on Mars. It's not a stationary lander like the ones on the Moon. It's a flying drone. A rotorcraft with 8 rotors arranged on 4 arms about the size of a small car. Think of it like a super advanced version of the Mars helicopter, except way bigger and way more capable. While the Mars helicopter Ingenuity was a technology demo that took short hops, Dragonfly is a full-fledged science mission designed to fly for years. And here's why flying works on Titan when it wouldn't work most other places. Titan's gravity is only 1/7 of Earth's, even weaker than the Moon. But its atmosphere is 4 times denser than Earth's. Low gravity plus thick atmosphere equals perfect flying conditions. On Titan, flying is actually easier than driving a rover. Dragonfly will make flights of several kilometers at a time, spending about 1 Titan day, that's 16 Earth days, at each landing site before moving on. Over its 3.3-year mission, it's expected to cover about 180 kilometers, visiting dozens of different locations. That's more ground than any planetary rover has ever covered. But here's the crazy part. Titan is so far away, about 1.5 billion kilometers, that radio signals take over 80 minutes to reach Earth. That means Dragonfly can't be controlled remotely like a normal drone. By the time Mission Control saw a problem and sent a command, Dragonfly would have already crashed, so Dragonfly has to fly itself. It uses artificial intelligence and autonomous navigation to scout terrain, choose safe landing sites, and execute flights completely on its own. It's basically a self-driving flying robot exploring an alien world with no human intervention. The spacecraft launches in July 2028 on a SpaceX Falcon Heavy rocket. Then it's a 6-year journey through space, including a gravity-assist flyby of Earth to pick up speed. In 2034, Dragonfly reaches Titan and begins one of the most dangerous parts of the mission: entry and landing. Titan's atmosphere is so thick that Dragonfly will use an aeroshell heat shield to slow down, just like spacecraft entering Earth's atmosphere. Then it deploys parachutes for the initial descent. About 105 minutes after hitting the atmosphere, at an altitude of 1.2 kilometers, Dragonfly separates from its parachute and fires up its rotors for the first time, beginning powered flight on an alien world. The initial landing site is a region called Shangri-La, near Titan's equator. It's an area of sandy dunes, but these dunes aren't made of sand. They're made of organic compounds, the hydrocarbon particles that have been raining from the sky for millions of years. It's basically a field of frozen gasoline. Dragonfly will spend time analyzing these dunes, measuring their composition, and understanding the chemistry happening there. Then it starts hopping from site to site, covering more and more territory. The ultimate destination is Selk Crater, about 80 kilometers away. This 80-kilometer-wide impact crater is special because it's thought to have once contained liquid water. When the asteroid or comet hit Titan, the impact melted the ice, creating a temporary lake that could have lasted for hundreds or even thousands of years. Think about what that means. You've got liquid water mixing with all those organic compounds on Titan's surface. Water, organics, energy from the impact, the 3 ingredients for life, all coming together in one place. If prebiotic chemistry ever happened on Titan, Selk Crater is where we'd expect to find evidence of it. Dragonfly carries a suite of scientific instruments designed to analyze Titan's environment. It has mass spectrometers to identify chemical compounds, cameras to scout terrain and document the surface, a drill to collect samples from beneath the surface, and even a seismometer to detect Titan quakes. seismic activity that could reveal details about the moon's interior structure. One of the key questions Dragonfly will investigate is how far prebiotic chemistry has progressed on Titan. On Earth, simple molecules like amino acids eventually organized into more complex structures that became self-replicating, the first life. Has similar chemistry been happening on Titan? Scientists describe Titan as a frozen-in-time version of early Earth. About 4 billion years ago before life began, Earth's atmosphere was probably similar to Titan's, rich in nitrogen and methane, with complex organic chemistry happening everywhere. Then something changed and life appeared. Studying Titan is like looking at a snapshot of what Earth was like right before that transition happened. But there's another possibility that's even more exciting. What if life on Titan doesn't need water at all? What if there's a form of life that uses liquid methane as its solvent instead of water? On Earth, water is essential because it's a great solvent. It dissolves and transports chemicals, enabling the reactions that power life. But methane is also a solvent, just a different one. It dissolves different things and enables different reactions. Recent research has even shown that cell-like structures, vesicles, could potentially form in methane at Titan's temperatures. If Dragonfly finds evidence of life in Titan's methane lakes, it would revolutionize everything we know about biology. It would mean that life isn't restricted to water. It would mean that the universe might be teeming with life forms we never imagined, living in environments we never thought to look. Of course, we shouldn't get ahead of ourselves. Dragonfly isn't specifically designed to detect life. It's designed to study habitability and prebiotic chemistry. But if something is there, Dragonfly's instruments might give us hints. Unexpected chemical signatures, anomalous compositions, patterns that don't fit purely geological processes. And even if Dragonfly doesn't find life, what it does find will be invaluable. Understanding how organic chemistry works on Titan will help us understand how life started on Earth. It'll help us know what to look for on other worlds. It'll expand our definition of habitability and give us new targets to search for life throughout the galaxy. The challenges of this mission are immense. Dragonfly has to survive temperatures that would freeze any moving part on Earth. It has to operate in near total darkness. Titan gets less than 1% of the sunlight that Earth receives. And it has to function for years with zero maintenance, making complex decisions on its own. That's why Dragonfly is nuclear-powered. Solar panels wouldn't work on Titan, there's just not enough sunlight. Instead, Dragonfly uses a radioisotope thermoelectric generator, the same type of power source used by NASA's Curiosity and Perseverance Mars rovers. It generates electricity from the heat of decaying plutonium, providing steady power day and night for the entire mission. During Titan's day, 8 Earth days of dim twilight, Dragonfly flies and conducts science. During Titan's night, another 8 Earth days, it sits on the surface, recharging its batteries from the nuclear generator, processing data, and preparing for the next flight. The mission team has already been testing Dragonfly's systems in some of the most extreme environments on Earth. They've flown test drones over California's Imperial Dunes, which resemble Titan's sandy terrain. They've tested components in giant chambers that simulate Titan's frigid temperatures and atmospheric pressure. And they've refined the autonomous navigation systems that will keep Dragonfly safe on a world where no human has ever set foot. This isn't the first time we've explored Titan, but it's by far the most ambitious attempt. The Voyager spacecraft flew by in 1979 and 1980, giving us our first fuzzy glimpses through the haze. The Cassini orbiter spent 13 years studying the Saturn system from 2004 to 2017, revolutionizing our understanding of Titan with over 100 flybys. And the Huygens probe gave us our only direct look at the surface in 2005. But Dragonfly takes it to the next level. Instead of a single landing site, we get dozens. Instead of static observations, we get mobility and versatility. Instead of a limited mission lifespan, we get years of continuous exploration. And maybe, just maybe, we get our first glimpse of alien life. The implications of finding life on Titan would be staggering. It would mean that life arose independently at least twice in our solar system. And if it happened twice in our solar system, it's probably happening all over the universe. Every star with planets becomes a potential harbor for life. Every moon with the right chemistry becomes a candidate for biology. But even if we don't find life, Titan has already taught us something profound. That worlds can be Earth-like without being Earth. That familiar processes, rain, rivers, lakes, weather, can happen with completely different chemistry. That the universe is far stranger and more diverse than we ever imagined. In July 2028, Dragonfly launches. In 2034, it arrives at Titan. And for the next several years, humanity will have a flying robot exploring one of the most alien yet strangely familiar worlds in the solar system. We're about to search for life in a lake of rocket fuel on a moon a billion miles away, using a nuclear-powered helicopter drone that flies itself. If that doesn't blow your mind, I don't know what will. This is the future of space exploration. This is Dragonfly, and this is just the beginning of our search for life beyond Earth.